So we just saw how to bring data into JMP and how to graph it using the graph builder. Now let's look at how we can actually perform a statistical analysis. I'll demonstrate this for just a completely randomized design with, and we're basically doing a one-way analysis of variance. There are lots of ways that you can do a one-way analysis of variance in JMP, but to make it more concise for analyses that we'll do in the future, I'm going to show this using just the fit model option. So this is found under the Analyze menu. There are a lot of different options under the Analyze menu that have different, more and very advanced analysis techniques. So the fit model is the kind of go-to one that does a lot of different ones. The distribution option is what you would use for just a univariate analysis, just looking at a single variable. Fit y by x does some simple modeling, but usually just has one independent variable. Tabulate is one way of summarizing reports, and we'll see this being used when we do the subsampling analysis. So let's go to the fit model and see what this looks like. So it opens up this window, and there are quite a few options to look at, but luckily most of them we don't really need to worry about too much. So here again we have all of our variables listed out just like we had in the graph builder. The first thing is we need to figure out the role of our variables and how to construct our model. So this y, this is where our response is going to go. So our response in this analysis is going to be hemoglobin. So I could either click and drag it over here, or I could highlight it and hit Y. Either one will work. So I'll just do that by hitting Y. And so once I put that in, we immediately got two things that came up: personality, standard least squares, and emphasis, which is effect leverage. I usually go to just minimal report for emphasis, just because that usually gives me the information that I want, partially because I don't quite understand some of the output and effect leveraging. So I usually just stick with minimal report. And so now I need to construct my model effects. So all I really need to put in here in this case is sulfamirazine. The intercept is included by default, and I don't need to include any residual analysis at this, or residual structure at this point, because it's a very simple error in this case. Later on we'll see how we can modify this to do analysis of covariance, blocking, and factorial experiments, all those sorts of things. So we'll need to then later on see the cross and the nested effects later on. But for right now, we don't need to worry about that. So I'm just going to stick with standard least squares, but let's just quickly look at some of the options. So they have some stepwise analysis, generalized regression. This new one, mixed model, can do some more complicated covariance structures. So they have quite a bit of options for different types of analyses, but in this course we can mostly stick with just standard least squares. And so that's it. That's all you have to do for this sort of simple analysis. So then once you've typed all this in, you just have to click on run, and this output comes out. So I'll go through this one by one. So the first thing that they show you is the summary of fit. They show you what the overall R squared is, which is not that great in this example, but not too bad. The adjusted R squared, which takes into account how many parameters you have in your model, your root mean squared error. So this is the square root of MSE right here, the overall mean of the response, and then how many observations were included in the analysis. So we had 10 per treatment, and there were 4 treatments. That's where 40 comes from. Here we have our overall analysis of variance table, and so this is the F ratio and p-value testing to whether our treatments are significantly different from each other or not. This will be a much more general analysis when we start including more effects than just treatments inside of our model, and we'll talk about that later. So notice that this p-value and F ratio match the ones down here, and we're going to mainly focus on the effect tests, which will then break down when we have multiple effects. It'll break down the individual tests for each effect. Notice that by default, JMP does not show you the parameter estimates, and the reason for this is because it uses a specific type of parameterization to get these parameter estimates. So for the most part, you want to ignore these because, again, these aren't really estimating the parameters in our non-full rank model, which is what we're usually using in this class. So notice all it shows here is 0, 5, and 10. It doesn't have an option for the 15. So we're not going to go into necessarily where these come from. I'm just going to say ignore these parameter estimates. Do not consider this analysis like a regression analysis. We're going to have to do an analysis based off of contrasts. So we have our overall differences between treatments is significant, so I need to do my contrast analysis. So how do I do that? So the way you do it is you click on the arrow next to affect details. And what that shows is first all of it says least squared means for your different treatments. So in this case, this is actually the same thing as my individual treatment means. So this is the average for my responses that had level 0. This is the average for level 5, level 10, and level 15. So these are basically my yi dot bars that we have been seeing over and over again. These standard errors are the square root of the variance of my yi dot bars. So we verified this in class earlier. So these are my means. If I actually want to construct contrasts, the way you do that is you click on this red arrow next to sulfamirazine. So these red arrows are key in JMP because these are all of the options we have for our analysis. They're in these drop-down menus. So if you click on this red arrow next to it, you have these options down here. So we have an Ellis means plot, and Ellis means contrast, Ellis means student T, Ellis means Tukey, Ellis means Dunnett, which is another type of confidence interval, and then a power analysis. So if I do Ellis means plot and scroll down, this is just going to give me a plot of all my least squared means up here, just to make it easier for me to kind of visually compare all these differences. So I'm going to minimize that for now. I'll just click on that arrow next to it to minimize it. So if I want to make a custom contrast, click on the red arrow and go to Ellis means contrast. And so this gives me an option with a bunch of pluses and minuses. So remember, contrasts, these are basically coming up with the coefficients for a contrast. So we need to make sure that these sum up to 0. And JMP is going to make us do that by looking at pluses and minuses. It is sometimes difficult to get a specific type of contrast I want by using pluses and minuses because JMP will do unpredictable things. But in this example, we'll see that it's not too complicated. So let me just do a single contrast here. So let me say I want to compare 5 to 0. So I want to do 5 compared to 0. So this is going to be what we showed earlier, y2 dot bar minus y1 dot bar, calling this treatment 1 or treatment 2 and this treatment 1. And so that's all I would need to do. I hit done, and then the test detail. So this is just testing whether that contrast is significantly different from 0 or not, and it says that it is. If I want to see what that estimate is, I click on test detail. So this is my estimated contrast. This is the standard error for that contrast. This is the t-value. And this is the p-value. And these are the sums of squares for that contrast. We saw that formula earlier on. So you can verify that if you square this t ratio, you're going to get this f ratio. So that's doing a single test of a contrast based off of a t or an f distribution with 1 numerator and 36 denominator degrees of freedom. But we also looked at cases of where we could do comparisons of or tests of multiple contrasts simultaneously. So I'm going to get rid of this contrast output just by clicking on this red arrow and going to remove. So let me make another one. So let's say I want to do 2, or let's say 3 linearly independent contrasts. So I'm going to do all the contrasts that compare 5 to 0, 10 to 0, and 15 to 0. So that's 3 linearly independent contrasts. And I have 3 numerator degrees of freedom, which means that that test should be equivalent to my overall test for my treatment. So I'm going to do 5 minus 0 again. I'm then going to go to new column to input a new contrast. Then I'm going to do 10 to 0, and then do a new one, and then do 15 to 0. And I believe if I try to click new column, it won't let me do another one because I've already defined 3 linearly independent contrast, so I can't do a test with another linearly independent one. And so my test detail for this, notice my sums of squares are the same as the overall test, my F ratio is the same, and my p-value is the same. So what I claimed appears to be correct. If I wanted to look at estimates for each of those individual contrasts, I could just click on this down arrow, and this tells me the estimates for all those contrasts, all of their standard errors. Notice they're all the same because we have an equally replicated design. These are the t ratios, and these are their individual sums of squares. So all of these contrasts are significantly different from 0 if we have 0.05 as our cutoff value. Notice their sums of squares don't all add up to the total sums of squares. That's only true if these contrasts are all orthogonal to each other, which is not the case here. But we could have constructed them. I believe I have those included in the lecture notes, a set of 3 orthogonal contrasts, but I'm not going to bother going into that. So I'm going to remove this, just not to clutter up so much. I might also want to look at confidence intervals of these comparisons. So JMP is only really capable of doing confidence intervals for pairwise comparisons. So the first option is that based off of just the t-distribution, no adjustment for multiple comparisons. If I click on that, I get this 2x2 table, which compares one to the other. So it's telling you that the estimate, the top part is mean I minus mean J. I is on the rows, J is on the columns. And then it tells you the standard error, the lower confidence limit, and the upper confidence limit. It tells us this is based off of alpha of 0.05, meaning that we have a 95% confidence interval. And we can see that all the contrasts that compare 5, 10, and 15 to 0 are significant, but none of the other ones appear to be significant. But we might be concerned about the fact that we're doing multiple comparisons here. We're doing 1, 2, 3, 4, 5, 6 different comparisons, so we need to do some sort of adjustment. So let me do, I'd say I do that off of the, using the Tukey adjustment. So I'm going to minimize this because there's no remove option for some reason. Oh, if I wanted to remove it, I can actually click on this red arrow and just uncheck students T, and that's how you remove that. So if I want to do Tukey pairwise contrast with a Tukey adjustment, I go down to Ellis means Tukey, HSD. And so I get the same sort of table, but now it is applied a Tukey adjustment to the pairwise comparison. So my confidence intervals are going to be slightly bigger. And what that ended up doing is it made this last contrast its confidence interval including 0, meaning it's not significantly different from 0 at the 0.05 level. But these two remain significantly different from 0. JMP does try to give you a visual way of seeing which treatments are similar and which ones are different. So it does this with these A's and the B's. So any level that doesn't have a letter in common are significantly different. So 5, 10, and 15 all share A. So none of these are significantly different from each other. And that's observed kind of from these 3 right here. But 5 and 10 have an A, 0 has a B. And so since these don't have a B also, this shows somewhat briefly that 5 and 10 are different from 0. So it is a little awkward at first using that. I usually prefer to just have the estimates reported automatically. So that's pretty much all you can do in JMP in terms of a contrast analysis. So there is some things that are limited in your ability to do analysis in JMP, and we'll see how you can do some of those things in SAS in another module.